Number one, the parent function that we'll be using is the absolute value of x, and the table for the parent function has x values that go from -2 to 2, and then the y values are as such. And so you need to be thinking about that table as you're graphing your related function. Our related function has a vertical shift up of 2 and a horizontal shift left of 3. And then the 1/2 that is inside that function in between the absolute value symbols is going to affect your horizontal movement. It's going to affect the x values in your table, and instead of halving them or multiplying those values by a half, it's going to be doubling them. So we're going to take all of our x values and double them. When you're working on the inside of your function, the numbers have an opposite effect of what you think they should have, and instead of moving to the right 3, you move left. Instead of halving your x values, you will be doubling them. And then here we have a negative on the outside of your function, and that is a vertical flip upside down over your x-axis, and it's going to flip over your imaginary x-axis, not necessarily the original x-axis. So let's go ahead and move our origin right here. And that is going to move left 3 and up 2. I am going to draw in an imaginary XY axis. And we're just going to pretend this is the original XY axis. And instead of going ahead and just graphing our transformed graph, I'm actually going to show you what the new table would look like. This is what is supposed to be going on in your head mentally as you are graphing. Our y values are unchanged. The numbers that are on our modified function do not change the y value. The numbers that are on our modified function are going to change the x values. It's going to take our x value and double it. So all your original y values remain the same, but your x values are doubled. So we're going to double everything that you see here. And 2 times -2 is -4. 2 times, that's that one. 2 times -1 is -2. 0 times 2 is 0. 1 times 2 is 2, and 2 times 2 is 4. So when you compare all of these x values, I have just doubled them all, and that is because of this 1/2 on the inside of my function. And then this is what we're really plotting, except we need to make sure that our graph is upside down. Okay, so instead of going, and I'm going to start here at 0, 0, which is already done. And then I'm going to do this point right here. Instead of going over 1 and then down 1 on our upside down graph, we're going to go over twice as far, so over 2 but still down 1. And then instead of going over 2, down 2 on our upside down graph, we're going to be going over twice as far, so over 4 and then still down 2. So my up and down movement has not changed, but my left and right movement has doubled off of the normal parent function. And then instead of going left 1, down 1, I'm going to go left twice as far, so left 2, but still down 1. And then I'm going to go, instead of left 2, I'm going to go over left twice as far, so that's going to be left 4, and then still down just 2 like I would on the original table. And then that is going to be a horizontal stretch for number 1. Okay, so let's go ahead and do number 2. And number 2 has a parent function of y equals x cubed. And the table for y equal x cubed has x values that go from -2 to 2. And then when you cube all these numbers, you get -8, -1, 0, 1, and 8. All right, let's look at our transformations here. We're going to be moving our graph down 2. We're going to be moving our graph to the right 2. I am multiplying by a half, but this time I'm multiplying on the outside of the function, not on the inside of the function. That 1/2 is on the outside before I cube. So that's going to change the y value this time. And it's going to do exactly what it says here. I am multiplying my function by a half, and so it's going to half our y values. It's not opposite. And then this guy right here is going to be a vertical flip upside down over our imaginary x-axis. And let's go ahead and look at the table. When we look at what this half is doing, it's going to take our y values and it's going to divide them by 2. It's going to half them. So all of our x values stay exactly the same, and all of our y values are chopped in half. And there we go. So all of our y values here have been just divided by 2. And then this is what I'm going to use to graph the shape of my function over here, the related function. My origin 0, 0 is going to be moved first, so I'm going to move that right 2 and then down 2 and put a dot. And I'm going to draw in my imaginary XY axis, and all of my y values that I normally move for my function are going to be halved, and our graph is going to be upside down. So normally I go over 1 and then down 1 for my upside down graph, but now I'm going to go over 1 and then down a half. I'm going to go down half as much, and then normally over 2 down 8. But I'm going to go over 2 down half as much, so it's going to be 1, 2, 3, 4. So I just graph that point, and I graph that point. Now we're going to go back 1, and then instead of down a half, because my graph's upside down, I'm going to go up a half. Whoops. Back 1 and then up a half, and then back 2, and then up 1, 2, 3, 4. For that last one. So my flipping the y values, I'm kind of just doing in my head and not showing it on the table. If I were to flip my y values right on the table, then all of the signs would change. And you can do that if you want to, but I typically just do the flipping in my head. All right, so that's that one. Now let's go ahead and do 3. The parent function for 3 is y equals x squared, and the table for x squared goes from -2 to 2, and when you square all of these numbers, you get this. And let's see what our graph is doing. It's moving up 3. To the right 2. Once again, it's going to flip vertically upside down over the x-axis, and then the 3 right here on the outside of the function. See, the 3 is being multiplied before you squared. It's not on the inside. That will affect your y value, and it's going to do what it says it's going to do. It's going to triple our y values. So our new table we'll have our y values tripled. Just want to see something quick. Yep. Our new table will have the y values tripled. And the x values aren't going to change. We're still going to have -2, -1, 0, 1, and 2, but our y values on the normal graph will be tripled. So 4 times 3 is 12. 1 times 3 is 3. 0 times 3 is 0. And then we get 3, and then once again 12. And I do have to remember that my graph's going upside down. So technically all of these numbers would be negative. But I just don't really draw that in, and I do it in my head. So those were the original y values. Down below, y values are tripled. And then I'm going to move my origin, starting with my origin, I'm going to move it to the right 2 and then up 3. And then I'm going to put my imaginary XY axis in. If you don't like it, you don't have to do it. I like it as a guide. And just don't forget our graph is flipped upside down because I don't have that showing in the actual new table right here. All right, so I'm going to graph this point first. Normally I go over 1, up 1, but we have to triple that and then also go upside down. So over 1 instead of down 1, over 1, down 3. And then instead of over 2, down 12, it's going to be, instead of over 2, down 4, it's going to be over 2, down 12. So that's, let's see, 8, 9, 10, 11, 12. Maybe down there. And then we'll do back 1, down 3. Instead of back 1, down 1, it's back 1, down 3. Instead of back 2, down 4, it's going to be back 2, down 12. And that's going to be about there. And then that's just going to make a vertical stretch. It's going to pull our graph down and make it nice and narrow. And then for number 4, we have the parent function as y equal the absolute value of x. Let's go ahead and draw that table in again. Goes from -2 to 2 on the x's, and then when you absolute value all those numbers, there's your table. So over here we are going to be moving up 2 and then to the right 3, and the negative sign on the outside of the graph is going to flip us vertically. Once again, I think all these graphs flip upside down. So flip vertically over the x-axis, and it's going to be over the imaginary x-axis wherever we move to. This number is on the inside of the function in between those bars, so it's going to affect the x's, and it's going to have the opposite effect of what you think. Instead of multiplying your x's by 3, it actually divides them by 3. So let's look at what the table is going to change to. The y's are not touched in this problem except for the fact that your graph's going to be upside down, and the x's are going to be all divided by 3. So -2 divided by 3 is -2/3. -1 divided by 3 is -1/3. 0 divided by 3 is 0. 1 divided by 3 is 1/3. And then 2 divided by 3 is 2/3. And so this is our new shape. All the x movement has been thirded. And then we are going to move to the right 3 and up 2 and draw on our new XY axis. It's pretty sloppy. All right, so 0, 0 is already graphed, and then we're going to move to the right 1/3, and then instead of up, remember we're flipping, so to the right 1/3 and then down 1. So right 1/3 and down 1. And then instead of going over 2, we're now going to go over 2/3 and then down 2. And let's go ahead and do this. Instead of left 1, we're going left 1/3 and then down 1. So our graph's upside down. Instead of left 2, we're going left 2/3 and then down 2. And then that's our graph. Make yours just a little bit neater than mine. I'm having cats crawling all over me while I'm trying to do this, and I just want to kind of get it done. Okay, we have y equals x squared as our parent graph. And the x values go from -2 to 2 on the parent graph. And when you square these numbers, you get 4, 1, 0, 1, and 4. And that table is something that you should be familiar with already. And we're moving down 3 and to the left 1. And that -2 is on the outside of the function, not in the parentheses. So that changes the y. It's going to double our y value. And then we also have a flip, a vertical flip over our imaginary x-axis, and our graph's going to be upside down. So if I look at what's happening to the table, and again, you don't do this when you're graphing. This is what's going on in your head mentally. I'm only showing you this because I want you to have a visual of what I'm talking about. So we're doubling all our y's. So we're going to take our y value here and double it to get 8. We're going to double 1 to get 2. 0 doubled is still 0. 1 doubled is 2. 4 doubled is 8. And then all of our y values have now been doubled on the parent function, and this is what we're going to be graphing. Don't forget, we're graphing all of these y values upside down. And our origin moves left 1, down 3. And then I'm going to draw in my imaginary XY axis. Okay, so instead of going, I'm going to start at 0, 0, and then do this one next. Instead of going over 1, up 1, or now in this case over 1, down 1 on my upside down graph, instead of going over 1, down 1, I'm going to go over 1 and down twice as far, which is 2. And then instead of going over 2, down 4, I'm going to go over 2 and twice as far, which would be 8. 1, 2, 3, 4, 5, 6, 7, 8. Just estimate it because we're off the graph paper. And then we're here. We're going to go back 1 instead of down 1, back 1, down 2. And then instead of back 2, down 4, we're going back 2, down 1, 2, 3, 4, 5, 6, 7, 8. And then go ahead and sketch your graph in. And hopefully it looks better than my graph here. And number 6, we have the parent function of y is equal to x cubed. And then the parent table goes from -2 to 2. And then -2 cubed is -8. And we have -1, 0, 1, and 8. And the change that we have is going to be on the x value. And so this 1/3 is on the inside of the function before you cube. It's on the inside of those parentheses. So that's going to affect your x value. And it's going to do the opposite of what you think it's going to do. It's not going to third your x. It's going to triple it. It's going to times it by 3. And then there's nothing that's affecting your y value. That's going to stay the same. And your graph is being shifted down 3 to the left 2. And then that guy is on the outside of the function before you're cubing. It's not on the inside of the parentheses. So that, once again, is another vertical flip upside down over your x-axis. It's going to flip all your y's upside down. Okay, so let's move our origin. We are going to be going left 2 and then down 1, 2, 3. I'll draw my XY axis. Didn't really figure out the new table yet, so we can do that in a minute. All right, my y values not touched. We still have -8, -1, 0, 1, and 8. But my x values are going to change, and they're all going to be triple. So I'm going to take negative 2 and triple it to get negative 6. I'm going to take negative 1 and triple it to get negative 3. 0 tripled is still just 0. 1 tripled is 3. And 2 tripled is 6. So it's our x movement that has been tripled. And our graph is upside down. So don't forget to flip upside down. So let's do this. 0, 0 already graphed. Instead of going over 1, I'm going to go over triple that, and I'm going to go over 3. So over 3, and then instead of up 1, we're upside down. We're going to go down 1. And then instead of going over 2, I'm going to go over triple that. So I'm going to go over 6. 1, 2, 3, 4, 5, 6. And then my graph's upside down. So instead of going up 8, I'm going to go down 8. 1, 2, 3, 4, 5. And let me scooch up a little bit. Where was I? 6, 1, 2, 3, 4, 5, 6, 7, 8. Just estimate it. Okay, so let's go, instead of back 1, we're going to go back 3 and then up 1. And then instead of left 2, we're going to go left triple that amount. So we're going to go left 6. 1, 2, 3, 4, 5, 6. And then up 1, 2, 3, 4, 5, 6, 7, 8. If you want to see the flip on the y's, you can come over here and flip them here. That would be plus, plus, and then minus, minus. There's your y's flipped. And I don't know what happened there. One, 2, 3, 6. 1, 2, 3, 4, 5, 6, 7, 8. I don't know what the heck happened there, but there's the point. And let's go ahead and sketch that in. Oh, this is really difficult to do on the tablet, but you can make your sketch a little bit better than mine. All right, that's 6. Number 7. I'm pretty sure for number 7, there's a 1 up here. And also for number 8, I'm pretty sure there's just a 1 up there. And I think this guy is squared. Oh, it's not letting me draw on it, but I think that's squared. So we'll say the parent function is y equals x squared. And then his table goes from negative 2 to 2. And then when you square these numbers, you get that. And that's one that you kind of have memorized already. And this is going down 1 to the right 3. My y value is getting thirded, chopping our y value by 3. And then our graph is going to be flipped upside down vertically. Let's go ahead and look at our table. Our y is being divided by 3. Our x's stay the same. There is no change in our x. And then we're going to end up with 4 thirds, 1 third. 0 divided by 3 is 0. 1 divided by 3 is a third. 4 divided by 3 is 4 thirds. And 4 thirds is just 1 and a third when you change it to a mixed number. So when we graph it, that's how we're going to graph it, 1 and a third. All right, let's move our origin. We're going to the right 3 and down 1. Then we're going to put in our imaginary XY axis. And I just got to remember that our graph is going to be flipped upside down. And all of these numbers in the Y column here are going to be opposite of what you see. So they're all going to be negative. All right, so let's start with 0, 0. And that's already graphed. And then our next order pair is going to be over 1. And then instead of up 1, we're going to go up a third. But instead of up a third, we're going to go down because our graph's upside down. So over 1, down a third. And then over 2. And then instead of down 4, we're going to go down 4/3, which is 1 1/3. So somewhere about there. Okay, let's graph this point. Instead of left 1, down 1, we're going to go left 1, down 1/3. Instead of left 2, down 4, we're going to go left 2, down 4/3, or 1 1/3. And then that guy's graphed. And all of this table stuff that I'm doing, that secondary table, if you can help it, you should be just mental mathing that. I'm only putting the table in so you can really understand what is getting changed with the numbers that are being multiplied by your function, whether it's on the inside or the outside of the function. Okay, the last one here, number 8. Our parent function, once again, I think we've done 2 of these so far, is the absolute value of x, which goes from -2 to 2 on the x's, and when you absolute these numbers, absolute value them, that's what you get. And I have a shift up and a shift to the left, and I'm multiplying my y values by 1/2, so your y value is getting chopped in half. And then once again, we're flipping over the imaginary x-axis as a vertical flip. Our graph's going to be upside down. And if we modify the original table, all of our x's stay the same, and it's the y values that are chopped in half. So 2 divided by 2 is 1. 1 divided by 2 is 1/2. 0 divided by 2 is 0. This y value chopped in half is 1/2. This y value chopped in half is 1. And then this is what we're going to be using, and the graph is upside down. So we're going to go to the left 2 and up 2. And put our imaginary xy table in. And then if you can graph your y values chopped in half and upside down without making an extra table, then go ahead and do that, because that's what you're supposed to be doing. All right, so I start with 0, 0 on this graph, and then I'm going to graph that point. Instead of going over 1 and then down 1, if it's upside down, over 1, down 1, I'm going to go over 1 and down half as much, down 1/2. Instead of going over 2 and then down 2, I'm going to go over 2 and down half as much, which would be 1. And then instead of left 1, down 1, left 1, down half as much. Instead of left 2, down 2, I'm going left 2 and down half as much, which would be 1. And there we go. Now, this wasn't a very efficient way to graph these functions. You are not supposed to be even looking at this table at all. The only reason that I put the tables in is so I could stress which value is being changed, whether it was your horizontal or your vertical movement, the x or the y movement. And so you could see it as I was talking about it, so it wouldn't sound like complete gibberish. When you do enough of these functions, you should be thinking of the original table and making those modifications in your head as you go. And if you can already do that, that's fabulous. If you can't do that at the moment, then you can go ahead and sketch this table down really quick, but it kind of defeats the purpose of graphing using transformations if you have to do this much writing and this much work. So all of these extra tables, if you can do it without them, then please do it, because it just takes a lot of extra time to have to write down those changes in a whole nother table.